Question 1. Now I thought this was pretty difficult for the first question on a paper. So the first thing we need to do is really to turn this 14 kilometers into centimeters. We're going to be dealing with centimeters. You can see that here and in the units. So first of all, turn kilometers into meters. Now there are 1,000 meters in a kilometer, so times it by 1,000. So that turns it into meters. And then to turn that into centimeters, we have to times that by 100, because there are 100 centimeters in a meter. So 14 kilometers is 1,400,000 centimeters. Now we're then told that the scale is 1 to 125,000. So something which is 125,000 in real life is 1 on the map. So to turn this real life number of centimeters into the number of centimeters on the map, we've got to divide by 125,000, giving us 11.2 centimeters. Now for part B, we're told that Luciana has a map of the scale of 1 to n. On her house is 4.8 kilometers from a station. On Luciana's map, the distance from her house to the station is 19.2 centimeters. Work out the value of n. So first things first again, turn this 4.8 kilometers into centimeters by timesing by 1,000 and 100, so that's 480,000 centimeters. Now that's the number of centimeters in real life, and 19.2 is the number of centimeters on the map. So if we divide 480,000 by 19.2, that shows us the scale. So the scale is 1 to 25,000, so n is 25,000. Question 2. So do as instructed. You also use your calculator to work out the value of this. And make sure you use that fractions button, which is the third one down on the left on most calculators. It's got the white rectangle divided by the black rectangle. Just do square root and then open up that fractions button. And using the blue button, make sure you put 8.9 plus 2.345 into the numerator. Use the blue circular button pointing downwards to get the denominator flashing. And then put 0.76 times 2.9 into that. Then use the blue button to the right to get out of the function, and then press equals, and we get this number here. And then obviously that to two significant figures. Now with two significant figures, we write down two numbers that our calculator is showing. So 2 digits here. So 2 point something. Do we round this 2 up? Yes we do, because the next digit is a 5, so our final answer is 2.3. Question 3. So a fairly straightforward substitution question. We've got to work out minus 7 squared plus 7 lots of 5. Now just be ever so careful with the p squared. Minus 7 squared means minus 7 times minus 7, which is plus 49. If you don't remember to protect the minus by putting the minus 7 in a bracket before you square, your calculator will give you minus 49. So that's the catch on this question. Make sure the minus 7 is protected in brackets, giving us a final answer of 84. Now for part B, we're told A is 100 when P is 11, so 100 equals 11 squared plus 7q. 11 squared is 121, so a fairly simple linear equation to solve. So take away 121 from both sides, giving us minus 21 equals 7q. Divide both sides by 3, we get q being minus 21 over 7, which is minus 3. Question 4. So we've got to find Stephen's median score. Now median means middle, so we need his middle score. He's spun the spinner 80 times, so his middle score will be his 40th, or if you like, his 40.5 spin. So we need to count down, adding up a running total of these frequencies until we get to his 40th spin. So after this row, he's had 5 spins. When we then add on this row, he's now had 5 plus 12, which is 17 spins. Nope, we still haven't got to the 40th. Add on another 16 spins, we've now got to 33. Nope, still haven't got to the 40th. It's only when we add on to this 32 that we get to the 40th spin, somewhere inside this 65. So the 40th spin is within these 32 spins. So what score did he achieve on this middle spin? He achieved a 4. So our final answer is 4. Now, to work out the mean score, we know to work out the mean we need the total divided by the number of spins. So what is the total number he achieved? Well, on 5 occasions he got the number 1, so that's 5 times 1, that's a subtotal of 5. On 12 occasions he achieved a 2, so how much is that altogether? Well, 12 2s are 24, and so on. 16 times 3, 32 times 4, 15 times 5. These are all subtotals of the amount in total that he achieved, adding up all the numbers. Add all of those up, we get 280. So he got a total of 280 from his 80 spins. So what's his mean score? Is 280 divided by 80, which is 3.5. Now, Stephen's going to spin the spinner once more. Use the information in the table to find an estimate for the probability the spinner will land on an even number. So the even numbers here are 2 and 4. So that's he achieved the 2 twice and the 4 32 times. So that's a total of 12 and 32, which is 44. So the chances of him getting even number is 44 out of 80. That's fine as a final answer because it didn't ask you to simplify it. But if you wanted to simplify it, 22 over 40 or 11 over 20 are simplified answers. But 44 over 80 would have given you full marks. Question 5. So for part A, start by multiplying out the brackets of the claw. 3 times 1 is 3, 3 times minus 2y is minus 6y. So that's it with the left hand side expanded. Now we want to gather all our y's onto one side and all our normal numbers onto the other. So it's easiest to gather all our y's onto our biggest number. Well, this is the positive number, so that's the biggest one. So let's get all our y's onto the right hand side. So to do that we need to choose to add 6y to both sides. So on the left that leaves us with the 3, and on the right we've now got 8y minusing the 7. Now to get all our normal numbers to the left, we therefore choose to add 7 to both sides, giving us 10 equals 8y. We then divide by 8, giving us y is 10 over 8, which is 5 over 4. Now that's fine as a final answer, or 1.25 is great as well. Now for part B, we've got to write down the inequalities shown on the number line here. Well, we can see that x is between 4 and minus 3, hence the 4 and minus 3. Now you've got to be then very careful about these dots. The filled in one includes the value of 4. So that's why x is less than or equal to 4. Whereas over here, the non-filled in one does not include minus 3. So that's why it just says x is greater than minus 3. Now also remember that you're reading it from the center here. So this obviously means x is less than or equal to 4. But over here, it's telling us that x is greater than minus 3. Now for part C, we solve this linear inequality just we would as a regular linear equation. So we follow through our algebra in order to make m the subject. So we start off by taking away 13 from both sides. So 2m is greater than or equal to minus 5. We then divide by 2, so m is greater than or equal to minus 5 over 2. So you could give that as your final answer, or alternatively m is greater than or equal to minus 2.5. Question 6. Now with part A, we've got to find the length of QR. So at this point it's just side, side, find a side. So it's going to be Pythagoras. We're finding one of the shortest sides, so it's a taking away Pythagoras. So QR squared equals 10.6 squared minus 5.9 squared. So popping that into our calculator, we get 77.55. Square root this, we get 8.8062 dot dot dot. So to three significant figures, 8.8. Do we round up the 0? Yes we do, because the next digit is 5 and above. So 8.81. Remember, three significant figures means 3 digits. Now for part B, we've got to work out the size of an angle, so we're going to be using SOHCAHTOA. So picture yourself at the angle, which is here. We know our opposite and our hypotenuse, so therefore we're going to be using sine, because sine is opposite over hypotenuse. So sine x equals our opposite side of 5.9 divided by our hypotenuse of 10.6. Inverse sine both sides to make x the subject. So x equals inverse sine 5.99 over 10.6. Pop that into a calculator, we get 33.821 dot dot dot. So to one decimal place, so one number after the decimal point, that is 33.8. Now for part C, this is just a bounds question. Write down the upper bound for the length of the line. Well, this is correct to 1 decimal place, so the absolute maximum it could be would be 12.45. Now do remember, theoretically that is wrong. The answer should be 12.449 recurring, but they like the symmetry of things. You'd happily say 12.35 was the lower bound, so they expect you to say 12.45 is the upper bound. Question 7. Well, we really should know just by sight that this is going to be a straight line graph, because there's no squares or cubes involved. And if we think of the right hand side written round the other way around, y equals minus 3x plus 5, we can see it's going to have a gradient of minus 3, so it's going downwards and it's going to cross the y-axis at 5. So it's very handy if you can just sort of picture the shape it's going to be, but if you can't, not to worry, just make sure you really concentrate when you plot some points. Now we do have to draw this graph all the way from x being minus 2 up to x being 3, but there's no requirement that you go and work out all the values, all the y values for those x values. So if I were you, I would just keep things simple and just take 3 simple x values of 0, 1 and 2. So just take 3 simple x values, substitute this into the function and see what y values pop out. So when x is 0, 5 take away 3 lots of 0 is 5 take away 0, which is 5, so that's generated the coordinate 0, 5. Secondly, when x is 1, 5 take away 3 lots of 1 is 5 take away 3, which is 2, hence the coordinate 1, 2. And when x is 2, 5 take away 3 lots of 2 is 5 take away 6, which is minus 1. So you only really needed 2 coordinates to get the line, but I think do 3 for luck just to make sure you haven't made a mistake. So plot those 3 points. That's showing you where the straight line is, but do make sure when you get your ruler out and draw in your straight line, it does stretch all the way from minus 2 all the way up to plus 3. Don't just draw the line between your 3 points. Question 8. So we've got to construct an angle bisector. So hopefully this is something you've practiced plenty of times before. And basically all an angle bisector is going to do is going to cut this angle in half using just a compass and a ruler. So step 1, get your little compass, do a small little arc. It doesn't matter how long, it's your choice. So I've done that here in blue. And the purpose of this is just to establish these 2 pinpoints you're going to use for your second and third arcs. So you then go and going to do 2 more arcs which have to be the same length. Can be the same length as this, or you can make it a bit bigger if you like, but the key bit is the next 2 arcs have to be the same. So first of all put the pin here and do an arc, and then put the pin here and do the same arc, and that establishes this point where the those 2 constructions lines cross. So then get out your ruler and draw a line from B through where these second and third arcs cross, and now that's your final answer. That red line there splits the angle ABC, but do remember to leave in these construction lines as the question says, because really this blue and 2 purple bits are your workings and your red bit is your final answer. Question 9. Now this is quite complicated really. There's sort of 2 bits going on here. We've got to construct and solve a linear equation, and then we've got to use our knowledge of exterior and interior angles to work out the number of sides. So first things first, this is an interior angle, this is an exterior angle, and an interior angle plus an exterior angle has to equal 180 degrees. Now you can also see that clearly they both form a straight line. So our starting point here is to say 4x plus 28 plus x minus 13 equals 180. So we've constructed an equation which we can now solve. So simplify the left hand side. We've got 5x plus 15. Take away 15 from both sides, divide by 5, and we get x equaling 33. So x is 33, so that allows us to work out the internal angle if we wanted to, but more importantly for us, it allows us to work out that the exterior angle is x, 33, take away 13, which is 20. So each exterior angle of this regular polygon is 20 degrees. Now we've then got to remember that the exterior angles always total 360 degrees. So if each of them is 20, how many of these exterior angles must there be? Well, that's going to be 360 divided by 20, which is 18. So 18 exterior angles, 18 sides. Question 10. So we need to form an equation of a line which is parallel to this line here. Now if it's parallel, it's going to have the same gradient. So really our starting point is to work out what is the gradient of this line. Now in order to find that, we really need to reorganize this into y equals mx plus c format. So starting here, I've decided to take away 8x from both sides to start with. So 2y equals minus 8x plus 5. I've then divided by 2, so y equals minus 4x plus 2.5. So bearing in mind y equals mx plus c, my gradient m is minus 4. So my parallel line, which is going to have equation L, is going to have a gradient of minus 4. Now what we also know about this line, it's going to pass through the point 2, 3. So we know a point on the line and we know the gradient. So I think it's best to use the formula y minus y1 equals mx minus x1, where x1, y1 is any point on the line. So x1 is 2, y1 is 3, and m is the gradient, minus 4. So y minus 3 equals minus 4x minus 2. Now I think that would give you full marks, because it doesn't state which format your equation has to be in, but I've chosen to rearrange mine into y equals mx plus c format. So I've multiplied out the bracket, minus 4x plus 8. I've added through to both sides, giving me y equals minus 4x plus 11. Question 11. Now the laptop decreases by 23% each year. So let's kick off by finding a percentage multiplier. So if you set up the 3 columns, original, change and final, make your original price 100, so we're really working in percent. Our decrease is 23%, so we're going to minus 23. 100 minus 23 is 77. Now a multiplier is the number that when we multiply 100 by the multiplier, we need to get this 77. So our multiplier is going to be 77 divided by 100, which is 0.77. So this multiplier is going to apply on each of the 3 years. You can see it's 3 years because we're from the 1st of January 16 to 1st of January 19. So that's 3 years worth of this multiplier. So it's 330 times 0.77 for year 1, times 0.77 for year 2, times 0.77 for year 3, or in other words 330 times 0.77 cubed. Now popping that into a calculator, we get $150.65 ... So correct to the nearest dollar, that's going to be $151. Question 12. Now in a way there are 2 ways to really think of this. I prefer the blue one on the left, but I know plenty of people out there teach it the other way in green on the right, so we'll quickly follow through both. They end up at the same point. So the way I like to think of it is, how are we going to undo a dividing by 3? We're going to multiply by 3. And how are we going to undo a dividing by 4? We're going to multiply by 4. So we've got to multiply each of the 3 terms firstly by 3, that's my bit in red. Then secondly we're going to multiply each of the 3 terms by 4, that's my bit in purple. So the 3's cancel here, the 4's cancel here, and I'm left with 4 lots of x plus 4 plus 3 lots of 2x plus 3 equaling 7 times 3 times 4. So so which is 84. So I get to this line here. Now from then onwards, it's just, we've got it all onto one line. We've just got to expand the brackets. So 4x plus 16 plus 6x plus 9. Gather up our like terms. So 10x plus 25 equaling 84. Take away 25 from both sides. Divide by 10. We get x being 59 over 10, which is 5.9. Now an alternative way of looking at it is just like when we, how do we add fractions? We need to have a common denominator. Now our common denominator is going to be 12, so we're going to multiply top and bottom of this first term by 4 and top and bottom of our second term by 3. Now you'll see that at that point, if you then go and choose to multiply multiply throughout by 12, we get this line here. and that's exactly the same line as I've got over here in blue. So there are two ways of doing the same thing, just a slightly different approach. Question 13. So if you can just pop this into your calculator and write 3.57 times 10 to the 7 equals the SD button, and it gives you the answer. Alternatively, if you just need to bunny hop along seven decimal places, that's your answer. Now for part B, work out the mean number of people per square kilometre living in Tokyo. So make sure you get this the right way round. It's mean number of people per square kilometre. So mean number of people divided by square kilometres. So the people is 3.57 times 10 to the 7 divided by the land area of 1.35 times 10 to the 4. This gives us 2,644.444 recurring. Now remember, we've then got to convert this into standard form. So remember, the standard form, rule 1 is the first number is between 1 and 10. So we're going to need the decimal point to be between the 2 and the 6, giving us 2.6. So that's how many places has the decimal point hopped along? 1, 2, 3. So that's 2.644 ... times 10 to the 3. But we're required to give our answer correct to two significant figures. So this first number has to be rounded to two significant figures. So 2.6 times 10 to the 3. Question 14. Now the numbers are already in order, which is handy. So find the middle number, the median number. So that's the middle number here. And then we need to find the middle number of the first half of numbers. So the numbers from the 1 to the 5. So that's the 3 here. And secondly, the middle of the numbers from this 6 up to the 15, which is this 11 here. Now the interquartile range is the number which is 3/4 of the way along, so the 11, to take away the number which is 1/4 of the way along, which is a 3. 11 take away 3 gives us 8. Question 15. Now we're being asked to work out angle ABC, which I'm calling angle X. Now, in order to be able to find that out, firstly we're going to work out angle Y, this angle AOC. And we can work this out because we know that this angle DAO and DCO, both of these are 90 degrees. That's because the lines DA and DC are tangents to the circle, and one of the circle theories tells us that the angle between a tangent and a radius is 90 degrees. So the angle between the tangent DA and the radius AO is 90 degrees, and also the angle between the tangent DC and the radius CO is also 90 degrees. Now if we then consider the quadrilateral, the four-sided shape AOCD, angles in a quadrilateral always add up to 360 degrees, so Y must be 360 minus 90 minus 90 minus 76, which is 104. Now another one of the circle theories tells us that the angle at the circumference is half the angle at the centre, so X must be half of 104, which is 52 degrees. Question 16. So we've got to use algebra. So kick off by letting X equal this recurring number, so 0.345455 and so on. Okay, the 4 5s are recurring. Now, because we've got the double dot, I need you to choose to multiply left and right by 100. 2 dots multiplied by 100, 1 dot multiplied by 10. So 100x equals, and everything moves across 2 decimal points, 34.545454 and so on. And what you'll see now is once we get to the second decimal point onwards, the recurring numbers are lined up. So now if we do equation 2 take away equation 1, we're going to get 100x take away x, which is 99x, and 34.5 take away 0.3, which is 34.2. Now I want to try and avoid divided by 99 here, because I don't like to have a decimal being divided by 99. I don't like to have a decimal as part of a fraction. So just at this step, I think it's just tidy to choose to multiply both sides by 10 to undo this decimal, and then at that point go and divide by 990. So we get x being 342 over 990. And then if we divide top and bottom by 18, we get 19 over 55 as required. Question 17. So we've got to make A the subject. So we've really got to unpack this equation. So first things first, let's undo this square root. So let's choose to square both sides. So we get x squared equals 2b minus a over 7 minus am. Secondly, we really want to get rid of the algebraic fraction. So let's choose to multiply both sides by 7 minus am. So x squared times 7 minus am equals 2b minus a. Now then remember, both terms have to be multiplied by the x squared, so make sure you had your 7 minus am in a bracket. So multiplying out the bracket, we get 7x squared minus amx squared on the left hand side. Now the secret now is to get all the terms which have got an a in it onto the one side. I'm going to choose the left, and all the terms that do not have any a's in them onto the other side, I'm going to choose the right. So I don't want this on the left hand side, so I'm going to take away 7x squared from both sides, and I do want this minus a on the other side, so I'm going to choose to add a to both sides. So at that point I get a minus amx squared equals 2b minus 7x squared. So just to repeat, both my terms on the left include an a, both my terms on the right do not. Now this then allows me to factorise the left hand side, isolating the a. So factorising the left hand side, I get a open bracket 1 minus mx squared close bracket. And for the first time I've now only got a cropping up once in the equation. So easy to finish this off now. I just need to isolate a on its own by undoing this multiplication by 1 minus mx squared. So I choose to divide both sides by 1 minus mx squared, giving me a final answer of a equaling 2b minus 7x squared over 1 minus mx squared. Alternatively, you can get this answer where basically top and bottom are just being multiplied, each term is being multiplied by minus 1. Same answer. Question 18. So over here on the left, I'm going to do all my ratio work, how I move between the various ratios. So I'm told to start with that the area of the two flasks, the thing I have in common, I know the area for both of the flasks. Okay, I know the area for flask A is 132, and the area of flask B is 297. So I know one height here, but the only 7. But the only ratio I know both sides, I know A and B, is for area. So my starting point has got to be the area ratio of 132 to 297. Now it's not essential to go and simplify this ratio, but it just makes the numbers a lot easier to work with. So I've simplified this down as much as I can. So I've divided both sides by 33, giving me a revised area ratio of 4 to 9. Now, how do I move from an area ratio to a length ratio? Well, I have to square root. So square root of 4 to the square root of 9, which is 2 to 3. So my length ratio is 2 to 3. So I can now go and work out part A, which is all about the height ratio. So I know my ratio is of A to B is 2 to 3. I know the height of A is 7, and I need to work out the height of B. So you can do it one of two ways. You can either look at the relationship between the 2 and the 3 and say it's 1.5 times bigger, so multiply the 7 by 1.5. Or alternatively, you can look sort of vertically and see how do I go from 2 to 7 and multiply by 3.5. So 3 times 3.5 is 10.5. But whether you've sort of focused on the horizontal ratio or the vertical ratio, you'll still get the answer of 10.5. Now part B is all about volume, so I need to go back over to my right hand side and work out my volume ratio. Now if my length ratio is 2 to 3, my volume ratio is 2 cubed to 3 cubed, which is 8 to 27. So that's my volume ratio, 8 to 27. Now I'm told that the volume of B is 567. I need the ratio, the volume of flask A. So looking vertically, I can see that 27 to 567 I've had to multiply by 21. So I've got to multiply the 8 by 21, giving me a volume of 168 for flask A. So just to recap on the ratios, to move from length to area you square, to move from area to length you square root. To move from length to volume you cube. How would you move from area to volume? You would square root and then cube. How would you move from volume to area? You would cube root and then square. Question 19. Now I think these histogram questions are not as bad as they look. You've just got to think what's going on. Now the key starting point, you've got to appreciate that each of these rectangles, for each of these rectangles we're going to draw in a minute, the area is the frequency. So first thing you should write down on the question paper is write the word area over these frequencies. These final answers have all got these areas up here. Now the distance is the length along the bottom. That is therefore going to be the base of each of your rectangles. So let's kick off by just working out the lengths of these bases. Write the word base up here. So 0 to 10 is a length of 10, 10 to 25 is a length of 15, and so on. So here is your base of your rectangle, here is the area of the rectangle, and we need to work out the height of each of these rectangles. Well, we all know that the area of a rectangle is base times height, so the height is going to be area divided by base. So take these areas in column 2, divide them by the bases in column 1, and it gives us these 4 heights here. So I've now just got to basically draw 4 rectangles which have got bases of 10, 15, 20 and 15, and these heights here. So my first bar goes from 0 to 10 with a height of 3.3, and then from 10 to 25, so a base of 15, a height of 2.6, and so on. And the only thing I really then had to be careful about is just choosing a sensible scale. Try and use a scale that pretty much uses up as much of the graph paper as possible. So there are 4 obvious big squares here, or 10 of the little squares. So I've just made this 1, 2, 3, and 4 would be up there. So that's the answer to part A. Now for part B, it says find an estimate of the probability that this person travelled more than 30 kilometres to get to the airport. So just draw in a little line at 30 and just consider what we need. We need to work out how many people are greater than 30. Well, clearly that's going to be the people in this area here, which we know is 12. It was 12 up here. And what fraction of this 36 people, this third rectangle, do we want? Well, can you see that we need 3 of these columns, but not this 4th column? Okay, so we don't want that 5 square column, but we do want these 3 5 square columns. So we want 3/4 of the 36, which is 27. So the number of people we're interested in is 27 add 12, which is 39. Now we're being asked to work out the probability the person chosen travelled more than 30 kilometres. So that's 39 out of the 120 people who were chosen, who travelled. So 39 out of 120. Leave it as a fraction. Always leave probabilities as fractions if you can. That's 39 over 120. Could simplify it, but absolutely no need. Question 20. So for part A, we've got to give our answer as so many lots of root 2. So we really need to simplify each of these 3 surds here into so many lots of root 2. So root 50 is root 25 times 2, which breaks down to being root 25 root 2, and the square root of 25 is 5, so that's 5 lots of root 2. Remember, what we're doing each time, we're trying to find 2 numbers that multiply to make, say, the 50, one of which is a square. So then moving on to the 128, well, that's 64 times 2. Square root of 64 is 8, so that's 8 lots of root 2. And the 200 is 100 lots of 2, so root 100 root 2, which is 10 root 2. So we've got 5 lots of root 2, add 8 lots of root 2, take away 10 lots of root 2, which is 3 lots of root 2. Now for part B, we've got to simplify this. So we need to no longer have a denominator. We need to undo the root A. Okay, the 10 will be fine because we can just divide each of the terms in the numerator by 10 at the last minute. But what we really need to undo is this square root of A being on the denominator. So how do we do that? Well, we choose to multiply top and bottom by root A. So that's what I've done here. So doing a claw, we've got 5 times root A, which is 5A, and then A root A, the second claw here. And on the denominator, we've got 10 times root A times root A. Well, root A times root A is A, so that's 10A. Now, once we've got to that point, we can then divide through by A, because each term in the numerator and the denominator has got A in common, so we can divide through by A. So at that point, we've got 5 plus root A over 10. And then, because we've got to give our answer in this format, 5 divided by 10 is a half. And root A over 10 is a tenth of root A. So our final answer is half plus a tenth root A. Question 21. Now I think on a question like this, you're not necessarily sure where you're going, but just really do what comes comes to mind. So really we can work out this square and we can work out this square. So remember, this means 10a minus b multiplied by itself. So 10a minus b times 10a minus b, and equally over here we're taking away 2a minus 5b times 2a minus 5b. So kick off by multiplying out the pair of brackets. So here we get 100a squared minus 10ab minus 10ab plus b squared. Be careful, minus b times minus b is plus b squared. And then tidying that up, we get 100a minus 20ab plus b squared. Now on the right hand side, we've got 2a times 2a, which is 4a squared, then minus 10ab minus 10ab plus 25b squared. Tidying up those two middle terms, so gathering like terms, we get 4a squared minus 20ab plus 25b squared. Now here you've got to be ever so careful. This taking away, this minus has got to apply to every single one of these three terms. So think of another claw here where you've got a minus 1 in front. So it's minus 1 times this, minus 1 times this, and minus 1 times this. So we actually get minus 4a squared plus 20ab, because we're minusing minus 20ab, and then minus 25b squared. Now you see at that point that the minus 20ab cancels with the plus 20ab, and we can simplify the a squared, so we get 100a squared minus 4a squared is 96a squared minus 24b squared. We can then go and factorise, taking out the 24, giving us 24 lots of 4a squared minus 2b, and then you've just got to recognise that this is a difference between two squares. Both this first term and this second term can be square rooted. So we've got the square root of 4a squared is 2a, and the square root of b squared is b. So we get 2a plus b, 2a minus b. Because you'll see if you multiply out that pair of brackets, you get 4a squared minus b squared. So that's your final answer. Question 22. So we're told when the biased coin is thrown 5 times, the probability of getting 5 heads is this. So basically the probability of a heads and then a heads and then a heads and a heads and a heads is this. So what must be the probability of just getting a head on its own? Well, that's going to have to be the 5th root of 32 divided by the 5th root of 3125, being 2 over 5. Because really working back is what we're saying is the probability of a head is 2 over 5. So if you needed to get a head and then another and another and another and another, it's going to be 2/5 times 2/5 times 2/5 times 2/5 times 2/5, which would give you 32 over 3125. Now, once you've worked out that the probability of a heads is 2/5, Obviously the probability of getting a tails is the rest to make it up to 1, which is 3/5. Now, given this knowledge, heads being 2/5 and tails being 3/5, we've now got to work out the probability of getting 4 heads and 1 tails when the coin is thrown 5 times. So 5 times. Now there are 5 ways we can get 1 tail. Okay, the tail can either come at the end, or second last, or in the middle, or secondly, or first. So there are basically 5 ways we can achieve this. Now each of these probabilities is going to be the same because they all comprise 4 lots of 2/5 being times together and a 3/5 being times to that once. So we don't have to work out each of these brackets individually. We can just work out any one of them and multiply that by 5 because all 5 are the same. So what I'm going to do is to work out what 5 lots of this first bracket is. So the 5 lots of heads 2/5, heads 2/5, heads 2/5, heads 2/5, tails 3/5. So multiplying that out, I get 240 over 3125, or if you want to simplify it, that's 48 over 625. Question 23. Now part A is fairly straightforward as long as you get it the right way around. We've got to pop -4 into the F machine first and then pop that output into the G machine. So be careful, it's F machine first, G machine second. So popping -4 into the F machine, we get 3 lots of -4 divided by -4 minus 2. So that's -12 over -6, which is 2. We now take this output of 2 and pop that into the G machine. So 4 lots of 2, which is 8 divided by 5. So 8/5, or 1.6. Now for part B, we've got to express the composite function fg in the form fg of x and give our answer as a single fraction. So we've got to pop x into the G machine and then pop that output into the F machine. So x into the G machine obviously just gives us 4x over 5, and then we've got to pop this into the F machine. So 3 lots of 4x over 5 divided by 4x over 5 take away 2. So I've then, so what have I done here? In the numerator I've just multiplied out. 3 lots of 4/5 is 12/5, so that's 12x over 5. And in the denominator, in order to take this away, I needed a common denominator, so I've turned the -2 into -10/5, and then subtracted the numerators, that giving me 4x minus 10 all over 5. Now I've basically got a 5 as the denominator up here, and a 5 as the denominator down here. So if I multiply a numerator and denominator by 5, these two cancel out. So I'm left with 12x over 4x minus 10, and then if I halve top and bottom, that gives me 6x over 2x minus 5. Now for part C, to find the inverse function, you've got to change the subject. So kick off by letting y equal your f function. So let y equal 3x over x minus 2, and then we've just got to go through the process of changing the subject. So multiply top and bottom by x minus 2, multiply out the bracket, giving us xy minus 2y equals 3x. You need to get all your x's, all the terms with x on one side and all the terms without x on the other. So I've taken away 3x and added 2y. So all my x terms are on the left, my y terms are on the right. I've then factorised my left hand side, divided by y minus 3, and I've changed the subject. I've now got x equaling 2y over y minus 3. Now remember, y is something you've just introduced into the question. It can't be part of your answer. So your final answer is your inverse function equals 2 lots of x divided by x minus 3. Question 24. So let's just write down what we know here. We know that OA is 4A. Yep, we got that. We know OC is 3C, and we're told that the point X is such that CBX in a straight line and CB to BX is 2 to 3. So C to B is 2, Well, b to x is 3. Now we're also told that y is such that cy is 2 lots of ax. So I've just popped this on my diagram to help me gather my thoughts. So this is what an ax looks like. And I need c to y to be 2 lots of this ax. So one lot of this and then another lot of this. So coming from c, okay, I've got c to y, it's got to equal 2 lots of this. So I'm sort of estimating that would be over here. So this is where my y is. Now I'm being asked to find, in terms of a and c, the vector from o to y. The vector from o to y. So let's have a think. So o to y is going to be o to c plus c to y. That's fair enough. And I know that o to c is going to be 3c. So now all I've got to do is work out what c to y is. Now c to y is going to be 2 lots of what a to x is. So I need to work out what a to x is. Now a to x is an a to b plus a b to x. Now a to b is easy enough. That's 3c. But b to x is going to be sort of 1.5 lots of this o to a. Can you see that if o to a is 4a, so c to b is 4a, and that's 2 lots of something, so really this is 2 lots of 2a, so this length needs to be 3 lots of 2a, which is 6a. So going back to this, my a to x is ab, which is 3c, plus bx, which is 6a. So bringing this, so my a to x is 3c plus 6a. Now my cy, as I know, is double this ax, 2 lots of ax, so that's 6c plus 12a. So back to over here, where I was saying my oy was an oc plus a cy. Well, I've now worked out that cy is 6c plus 12a. So overall, my o to y is 9c plus 12a. Question 25. Now this is really tricky, so unless you really are chasing every mark, I wouldn't worry too much about this one. So let's think about our pentagon. What do we know, looking at the pentagon base? We know that each exterior angle is going to be 360 divided by 5, which is 72. So from the interior angle point of view, which I'm calling 2y here, okay, we know that 2y is going to be 180 minus 72, so that interior angle of a pentagon is 108. So this angle here, where I'm splitting my pentagon into 5 isosceles triangles, my y is going to be 54 degrees. So using the sine rule, I can say that OC over sin 54 equals 8 over sin 72, allowing me to work out that the length OC is 6.805. So now I'm going to go and look at this right angled triangle here, OMC, and I know that the length MC is half of an 8, which is 4. I've just worked out the length OC is 6.805, so I can work out the length OM using Pythagoras to be 5.5055. So I've worked out a number of various lengths. Now let's go and look at the question. We've got to calculate the size of the angle A to P to M. Now I'm going to break this angle up into angle A to P to E and O to P to M. So let's start off by looking at the angle O to P to M. Okay, so this angle in red at the top, which is part of the angle APM. I know that O to P is 10, and I've just worked out that O to M is 5.5. So I can work out using tan theta, I'm calling the angle OPM theta, tan theta equals opposite over adjacent equals 5.505 over 10. So inverse tanning both sides, I get the angle OPM to be 28.835 degrees. So that's the angle O to P to M. Now I need to add on to that the angle from A to P to O. So just looking at my right angled triangle A to P to O, I know that A to O is another one of these lengths to the middle, so I know that that is 6.805, and my height from O to P is still 10. So using tan again, I can go and work out that the angle A to P to O is 34.236. So my total angle from A to P to M are these two angles added together, the 28.835 added to the 34.236, which is 63.07 ... which is 63.1 degrees to 1 decimal place.